Hello everybody, Mingalapa from Myanmar. Um, we are offering open lectures in Clicktalk Engineering. My name is Teng Tai. My open lectures is mechanics, and the reason we're trying to select mechanics is because it is one of the most important subject for engineering and science students. And of course, if you are sitting for an A level exam, mechanics is really important subject for you. So do subscribe to our channel and study with the previous videos. So in the previous videos, we have already shown you how to measure the acceleration due to gravity. So the value of g from simple experiment and theory on the free fall. Apart from that, we have also derived the equation to find the distance traveled if you know initial velocity, final velocity, and the constant acceleration. So this is what basically we have done in the previous videos, and today we are looking at the total distance traveled by an object which is moving at constant acceleration, but the total distance will be derived by using only the initial velocity, the acceleration, and the time. So if you compare in the previous videos, we have the total distance traveled. We have the equation for total distance traveled by using the initial velocity, final velocity, and the acceleration. And today we will derive the equation for the distance traveled just using the initial velocity, constant acceleration, and the time. Right. So without any further ado, let's just try to look at the equation straight away. So as you see in this graph, we have the speed time graph for constant acceleration motion, and you can see here at time t is equal to 0, the object initial velocity is u, and for the final velocity is v, and the time taken is t here. So your object is accelerated from initial velocity u to final velocity v within the time t. As you remember, we have already derived the total distance to travel is just area under the curve, which is shaded in the green color here. So if you want to find the total distance, it's just the area under the speed time graph. And in the previous video, we have already proved that this total distance traveled, the area S is just equals to u plus v by 2 times t. And of course, u plus v by 2 is the average speed of the object from time 0 to t or from u to v. So in fact, average velocity, if you have to learn about it, you can look at our previous video, or you can just look at just remember just initial velocity plus final velocity divided by 2, which is the average velocity. And if you multiply the average velocity with time t, you will get the total distance s. So and based on that, we have already derived the equation for the total distance without having the time expression, so which is exactly this equation. We have just derived that. Sorry about yeah. So if you look at this equation, we have the total distance s here. It can be just found by using this equation: v squared is equal to u squared plus 2as. So this equation is used when you know the initial velocity, the final velocity, and the constant acceleration. And of course, there's no time expression. This is the advantage of this equation. Even you don't have the time information, you still can find the total distance using this equation. And opposite to that, in today's derivation, we were trying to derive the total distance equation without the final velocity effect. So let's try to have a look at that. So we have the final velocity equation from the constant acceleration, which is just v is equal to u plus a times t. And now we want to find the total distance traveled without the knowledge of the final velocity. So what we can do is, in place of v here, we can substitute this expression. So u plus 80 will be substituted in this in place of v here. So your s will be just as is equals to u plus, and in place of v, u plus at divided by 2 times t. And of course, u plus u is 2u, so your numerator will be just 2u plus at divided by 2 times t. And now if you split the division here, 2u by 2 is u, and multiply by t is ut, and at by 2 times t is just at squared by 2, or half at squared. And now you have already shown the total distance traveled by an object which is accelerating at constant acceleration can be just found by ut plus half at squared. And now again, if you notice this equation, we can find the total distance without the knowledge of the final velocity. So if you know the initial velocity, the constant acceleration at the time, you just can find the total distance traveled straight away using this equation, right? And as I have pointed out at the beginning of this lecture, total distance can also be found by this equation, v squared is equal to u squared plus 2as, and this is used when you don't know the time. So the two equations are of course quite different, and of course the conditions you apply in these equations are also quite different. So again, v squared is equal to u squared plus 2as is used to find the total distance traveled when there is no time information, and the equation s is equal to ut plus half at squared will be used when you don't know the final velocity. So now after you understood the difference between the two equations and the condition you apply, let's try to look at the with one of the example here. So again, I just want to recall this equation used to find the total distance traveled when you don't know the final velocity, and another equation used to find the total distance traveled when you know the final velocity. So now let's look at an example. So in this example, you are asked to find the distance traveled by a car which accelerates at 5 meters per second square from rest in 10 seconds. So if you try to look at the given parameter, so we know the car is accelerating at constant acceleration because the acceleration 5 meters per second square is just a constant, it does not change. And you are asked to find the total distance traveled, and the car just started from rest. So this means the initial velocity is 0. So you know the initial velocity u is 0, and the acceleration is constant, and the value is 5 meters per second square. And you also know the time, t is just 10 seconds. So if you analyze the given data, there is no information about the final velocity. All you know is just the initial velocity, 0, the constant acceleration, and the time. And you are asked to find the total distance, and of course the exactly match the equation that we have just derived. So we will just use the total distance equation, s is equal to ut plus half at squared here. So u is just 0, a is just 5 meters per second square, t is 10 seconds, so 10 second square, 10 square second square, and second square will just cancel out, and you will just have half time, 5 times 10 square meter. And of course, if you work out the numbers, you will have 250 meter as your answer, right? So this is just a very simple example of the equation for constant equation for finding total distance traveled for the constant acceleration motion without the knowledge of the final velocity. And I hope you see the advantage of this equation, right? Again, the advantage of equation, you don't have to find the final velocity to get the total distance because you know initial velocity, acceleration, and time. So you will just straight away applying this equation. So now basically, looking from the previous video and these videos, you are very much familiar with the two equations for finding the total distance. The first one is v squared is equal to u squared plus 2as. You use it when you don't know the time. And the next one today is s is equal to ut plus half at squared. You use this equation when you don't know the final velocity. So just trying to differentiate between the usage of these two equations, and of course later we will use this equation in modeling the projectile motion, which is of course the main content of this special lecture series. Starting from next week, we will do the projectile motion. So stay tuned, and subscribe to our channel. And I wish to see everybody in the next video. So with that, we'll just say goodbye. Bye bye.